Hello, everyone. So this is going to be the first video for Kin 376 for the assignments. Some will say homework, some will say assignments, but they're all assignments. And the purpose of these is not necessarily to go through each question and give you the answer, but to kind of give you an idea of how to work through this stuff so that you can practice with these. These are worth 25 points. But this will come in handy when you start taking your exams, because you won't see these exact questions. They won't be worded exactly like this in the exam, but they will be similar questions. So let's get started. So the first question is really a conversion question. Convert 59.8 meters per second to miles per hour. So really what we're looking at is you have 59.8 meters per second, and you need to convert it to miles per hour. You can go about this two different ways. First, you can convert meters to miles, and then seconds to hours, or vice versa, seconds to hours, or meters, and then meters to miles, okay? I'll say that again, is you can start by going from meters to miles, and then converting seconds to hours, or you can start by converting seconds to hours and then meters per mile. And it's very simple. We've seen it you should have seen it in the review of math, I think, lecture. But it's kind of simple as you're going from meters per, got to get my pen here. You're going from meters per second to miles per hour. So you can I'll start with converting meters to miles first. So we kind of know as well, okay, well, there's roughly 1 kilometer for every 1,000 meters. And this is where we start looking at this. We're looking at canceling stuff out, okay? So we can cancel off meters there, and then we need to cancel kilometers. We do know that for every 1 mile, there is 1.609 kilometers. So once again, we can get rid of our kilometers. And then you can do something similar as well for time. We need to cancel this time variable here. So what we can do is we need to have our seconds up top and eventually our hours on the bottom. So we know that there are 60 seconds. Sorry, my pen is spazzing out a bit. We know there's 60 seconds for every 1 minute. So we can cancel this out. And then we know that there's 60 minutes for every 1 hour. So essentially what you're doing is you're just working out this math problem right here. I won't, like I said, my goal is not to give you the answer, so I won't continue with this. But if you follow this logic up until hours, you should have no problem at all. So the last remaining questions are all trig questions. We've gone over it a bit already. And once again, this is kind of going back to if you took a geometry class in high school, or you took it, taken it already in your undergraduate degree. But essentially, we're looking at solving triangles. Okay, this is the kind of classic solve the triangle question. So I'm not going to go question by question here, but I'm going to do a bit of drawing. Hopefully I'll have space to do it. So I'm going to get rid of all this to give myself some space. All right. So for all these questions, just like in biomechanics, just like this whole semester, we're really looking at is right triangles. So if we draw a right triangle like this, it's not perfect, that's because I'm a terrible drawer. We have our right triangle. Generally, we have theta right here, and then this is our hypotenuse. This is our opposite side. We call it opposite because it's opposite of theta right here. And then this is our adjacent side because it's adjacent to theta. So when we look at this, we can use our common trigonomic functions, which is sine, cosine, and tangent. And we kind of had our mnemonic device, which is that SO, CA, TOA, which I'll do sine first, but it's basically saying sine of theta is equal to the opposite over the hypotenuse. Cosine of theta is equal to the adjacent side over the hypotenuse. And then tangent of theta is equal to the opposite side over the adjacent side. Okay. You can use those to solve almost all of these questions. However, there is another way you can look at this. I'm going to delete this again. We'll kind of start from scratch. Another sort of tool we use in physics, biomechanics, trigonometry, geometry, algebra is we look at Pythagorean's theorem. Okay, so this is our right triangle again. Here's theta. And we say that we label each side A, B, and C, with C always being the hypotenuse. And we say that A squared plus B squared is equal to C squared. And so if we see number 4 right here, you're given the opposite and adjacent. So once again, if you wanted to relabel this stuff, I'll just relabel it just for the sake of consistency. So we have our right triangle here again, right triangle. And we say that this is H for hypotenuse. This is O for opposite. This is A for adjacent. We see that A squared plus O squared equals H squared. Same thing as we said, A squared plus B squared equals C squared. Now, if you're looking at 4, well, you've got everything you need. You've got your 2 variables to solve for H. Then eventually you're going to need to solve for the angle. This is where it gets a bit tricky. Generally, when we look at any physics problem, trigonometry problem, algebra, biomechanics problem, is you never want to solve any problem that has more than one unknown. And when I say more than one unknown, this includes any sort of variable you've calculated. Is we could say, well, I could use H in my calculation here because I did solve for it earlier. But you shouldn't do that simply because that answer, because you're rounding it to 3 significant figures, becomes inaccurate. So the kind of saying is garbage in, garbage out. If you're using an inaccurate or imprecise number to then calculate another number, that end result is going to be more imprecise. So generally, you want to use the data that you have to solve for the unknown. So this is the data you have. So if I'm going to delete stuff because I'm working on a tiny screen and I only have so much real estate to use. If we have opposite and adjacent and we're trying to determine theta right here, we do know we can go back to our SOHCAHTOA rules and we can say, okay, well, tangent TOA, we can use this one right here. We say the tangent of theta is equal to the opposite over the adjacent. Now we've got pretty much everything we need. We've got this one, and we just need to figure out theta. Now, if you're looking at this algebraically, you could say, well, I can just divide by tan. Tan is a function. So it's not a variable that you can divide, multiply by, or anything like that. It's a function, same as a multiplication sign, division sign, square root sign, anything like that. So you have to get a little tricky. on your calculator, there should be, whether you're using a smartphone or you went and bought a scientific calculator or you're using one of those graphing calculators, there is going to be something usually in the top left corner. It'll say something like second, or have an arrow pointing, and you'll get more options. What you're really looking for is the inverse of tangent. It would look something like this. Tangent, and then a -1 superscripted over it. That's basically saying this is the inverse of tangent. So you could use this instead of dividing both sides by tan, which your computer will, or your computer or calculator or phone will flip out and say you can't do that. It's illegal. The cops are coming for you as we speak. Is you can just use the inverse tan function to solve for this. So instead of dividing both sides by tan, which you can't do, you can simply take the inverse of tan, multiply that by the opposite over the adjacent. And that will give you your answer for theta in degrees. Remember, you're using three significant figures for all of the questions unless it's otherwise indicated. And then finally, just a few things just to remind you. I'm going to delete this, delete all 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 this. Is for each of these questions, kind of rules of the class, is always include your units, okay? And it even says right here, questions 2 through 5 need to be in meters, okay? Like we talked about in the introduction for this class and the review of math lectures, we use SI units. That includes meters. So some of these, you look at question 4, I'm giving it to you in inches. So what I would suggest, if you go onto Canvas and look at the cheat sheets, or you can just look up the conversion ratios if you'd like, just Google them, is you're going to need to convert your final answer for, in this case, H to meters. What I would suggest you do, and this is kind of the proper way to do it, is solve your question first, then convert it. If you convert it beforehand, once again, you're entering in imprecise numbers, and then your final answer is going to be more and more imprecise. Same thing with number 5. Your units are in centimeters. You need to put them in meters. Okay, so know the conversion from centimeters to meters. It's metric, so it's always going to be by some multiple of 10. So I hope this helped. And remember, once again, we're using 3 significant figures. That includes the rule we learned where leading zeros and ones do not count as a significant figure, just the leading zeros and ones. So I hope this helped get you started. I'm going to release a video for each homework assignment, or any of the assignments. I'll release a video for them. And I hope they kind of help clear up what is needed for these assignments, since we're doing this all online and I don't get to kind of tell you this stuff in class, or if we're doing this over Zoom or something like that, I can't quite keep you up to date with this stuff. Obviously, if you have questions, feel free to email me, or if you've joined the Slack channel, feel free to get in touch with me through Slack. So I hope this helped, and goodbye.